You may feel familiar with the story of Apollo 11 and NASA's first crewed landing on the moon. Yet there is an important part of that story that rarely gets mentioned. Neil Armstrong and Buzz Aldrin were not the only ones reaching the lunar world around that historic moment. On that same fateful day in 1969, the Soviet Union had its own lunar mission underway. Most people never heard about it. In reality, Soviet spacecraft had reached the moon long before NASA, and Soviet engineers continued sending missions to the lunar surface long after the American astronauts had returned home and celebrated their final triumph. That remarkable side of the space race has almost always been hidden beneath the enormous legend of Apollo. But the objects the Soviet Union placed on the moon tell a very different story, one that can completely change the way we understand the competition between the two superpowers. The story began in October 1957, when the first artificial satellite was launched into orbit around Earth. Sputnik marked a turning point in the Cold War between the United States and the Soviet Union. The rivalry was no longer limited to nuclear weapons. It was becoming a technological contest, and that contest would soon extend beyond Earth itself, reaching into the solar system. The United States responded quickly. Just a few months later, its own satellite, Explorer 1, climbed into orbit. Before long, launching objects around Earth had become almost routine on both sides. But an orbital stalemate was never going to satisfy either country for very long. Someone had to move ahead, and the moon was the obvious next target. At that stage of the space race, only one side had the machinery needed to make the journey. That side was the Soviet Union. The key to its advantage was a massive rocket known as the R-7. It had first been developed as the world's earliest intercontinental ballistic missile. Fortunately for humanity, however, it was never used as a nuclear weapon. Instead, the design became an orbital launch vehicle. The Soviet program also had two extraordinarily talented engineers working on its behalf, Sergei Korolev and Valentin Glushko. Korolev had a remarkable talent for managing enormous, complicated design projects. Glushko specialized in engines. The two men had been bitter rivals since they were young, and their conflict would eventually help tear the Soviet space program apart. At this point, though, they were able to work together well enough to share the spotlight. When two determined overachievers contribute to the same project, the result can become far more powerful than the original job requires. The R-7 had begun as a missile, but its design was so heavily built that it became one of the most famous rockets in the history of spaceflight. At its base were 5 powerful engines. Together, they generated the enormous energy necessary to escape Earth's gravity and send a human-made object toward the moon. The Luna 1 and Luna 2 probes were housed in shells roughly the size of a beach ball, similar to the casing used for Sputnik. Their central objective was remarkably straightforward: strike the lunar surface. There was no attempt to land gently. There was no plan to enter lunar orbit. The goal was simply to aim the spacecraft at the moon and hit it, almost like firing a cannonball across space. If the mission worked, the probe would become the first object made by humans to reach another world beyond Earth. At the time, that was an extraordinary achievement to attempt. Success, however, was far from guaranteed. Luna 1 launched on January 2, 1959. Korolev and Glushko had created an upper stage for the R-7 that would ignite after reaching space, then propel the impact probe toward the moon. The spacecraft also relied on an automated guidance system, which was an impressive piece of technology for that era. Luna 1 represented so many historical firsts that it is hardly surprising the launch did not go exactly as planned. The probe missed its target by roughly 5,000 kilometers and passed cleanly beyond the moon instead of striking it. That was the purpose of building more than one spacecraft, though. In September of 1959, the second Luna mission lifted off. This time, the aim was accurate. The probe weighed approximately 150 kilograms and carried 6 scientific instruments designed to study the moon. It also had 2 unusual objects on board: a pair of metal spheres that were meant to explode. Their purpose will become clear shortly. The instruments were controlled by a small computer inside the spacecraft. Power came from a mercury-zinc battery, a compact source that provided a steady voltage for a long period. Batteries based on the same chemistry are still used in hearing aids because they offer dependable performance and extended operating time in a very small package. Despite its simple design, Luna 2 produced two significant scientific results. First, it demonstrated that the Moon does not possess a magnetic field. Second, it confirmed the existence of the solar wind, the continuous flow of electrically charged particles streaming outward from the Sun. Then Luna 2 completed its main assignment. It slammed into the Moon in a region known as the Sea of Rains. But the probe left more behind than a fresh crater. Those two metal spheres were between 8 and 13 centimeters across. Their outer surfaces were covered with small Soviet plaques pressed into titanium. Inside, however, each sphere contained an explosive charge. When the spheres struck the Moon, they burst apart and scattered the Soviet emblem across the lunar ground. The idea was to create lasting physical evidence that human technology had reached another world. Whatever happened in the future, the Soviet mark would remain there as a permanent record of the achievement. Soviet leader Nikita Khrushchev even presented a replica of one of the spheres to United States President Dwight Eisenhower. It was an extraordinary display of confidence, a very public way of showing who had reached the Moon first. The gesture probably irritated the Americans, but there was little they could do at that moment. NASA still did not have a rocket capable of matching the power of the R-7. And the Soviet Union was not finished. Luna 3 was already prepared for launch, and this mission would reveal something that no human being had ever seen before. The next probe departed only 1 month later, in October of 1959. It was a larger spacecraft with an even more historic assignment. Luna 3 carried many of the same kinds of instruments used by the earlier probes. Its most important addition, though, was a set of cameras. These became the first cameras ever sent into deep space. Designing a camera for the environment beyond Earth was not easy. Soviet engineers had to determine which photographic film could survive the severe temperature changes and intense radiation exposure of space. Producing a usable image depended on finding the right chemical formulation. Then, an astonishing piece of luck helped them. An American spy balloon crashed inside Soviet territory. The Soviets knew that balloons of this type were capable of taking photographs from an altitude so great that it was effectively at the edge of outer space. They removed the camera from the spy balloon's equipment and adapted it for the Luna 3 probe. The engineers also had to invent a way to develop the photographs without bringing the film back to Earth. They built an automated processing system that exposed and developed the film in space, producing a negative. After that, the spacecraft scanned the film with a light tube similar to the one used in an old cathode ray television, except that the process operated in reverse. The scanned light was then converted into radio signals, using a system comparable in principle to a fax machine, and transmitted all the way back to Moscow. Every part of this operation had to work remotely. There was no astronaut available to adjust the camera, repair the film, or process the images by hand. An array of solar panels wrapped around the spacecraft and supplied its electrical power. Temperature control depended on mechanical vents. When the probe became too cold, the vents closed. When it grew too hot, they opened. These simple systems allowed the spacecraft to continue functioning while it traveled around the Moon. Luna 3's primary goal was to fly past the Moon and photograph the hemisphere that Earth never sees. People often call this region the dark side, although that name is misleading because the far side receives plenty of sunlight. What made it mysterious was not a lack of light, but the fact that it always remained hidden from observers on Earth. Sunlight is still falling on that hidden hemisphere. We simply cannot see it from Earth because the Moon keeps the same face turned toward us. The reason for that arrangement is a separate story, and it is not important here. What mattered in that era was that no human being had ever seen the Moon's far side. The Soviet Union was preparing to change that. Luna 3 faced an unusual communications problem. To photograph the far side, the probe first had to travel behind the Moon, where it would disappear completely from Earth's view. After taking its pictures, it had to swing around the Moon and begin moving back toward Earth before it could transmit anything. That meant the spacecraft needed to follow an extremely precise trajectory using the moon's gravity to bend and redirect its path. Working out that route demanded serious computing power. Soviet engineers relied on one of the earliest supercomputers in the world, a machine built in Russia and named Strela 1, or Arrow. It occupied roughly 3,200 square feet, contained more than 6,000 vacuum tubes, and performed the calculations needed to send Luna 3 around the moon with the correct gravitational assist. During the photography sequence, the probe also used thrusters powered by compressed gas to keep itself steady while its cameras were taking long exposures. For its time, Luna 3 was an astonishing achievement in engineering. The spacecraft successfully returned photographs of the moon's far side, images captured from space of a region no one had ever observed directly. The result marked a major escalation in the space race, and people around the world were beginning to understand how quickly the Soviet program was moving. The American space program was falling behind, while the Soviet Union showed no sign of easing its pace. As the 1960s began, both nations started developing plans to send human beings to the lunar surface. Most people are familiar with the broad outline of the American effort, but the Soviet Union was pursuing an equally remarkable program, and parts of it were even more ambitious than anything the National Aeronautics and Space Administration was planning. The Soviet strategy was divided into three major parts. The centerpiece was a human landing program, and it was enormous in every sense of the word. Sergei Korolev was developing a gigantic launch vehicle called the N-1, but two supporting efforts were being built alongside that main project. One involved an automated rover that could travel across the moon and investigate its surface. The other was a robotic lander designed to examine the lunar soil at close range. That scientific work was essential because, despite all the excitement surrounding a crewed landing, no one actually knew what the lunar ground would be like. At the time, scientists and engineers considered several possibilities. The surface might be solid bedrock, or it might be covered by a deep layer of loose dust with a consistency similar to quicksand, capable of swallowing anything that came down onto it. Clearly, the second possibility would create a serious problem for a landing spacecraft, or for an astronaut trying to stand there. Before sending people, it made sense to settle that question with machines. The competition therefore shifted toward a very specific goal, becoming the first nation to achieve a soft landing on the moon. Reaching that milestone would not be easy. The Soviet Union's first attempt was Luna 4, launched in 1963. A navigation problem sent the spacecraft past the moon instead of onto it. Luna 5 was aimed correctly, but its landing engines failed and the vehicle crashed. Related difficulties struck Luna 6, Luna 7, and Luna 8. One failure followed another, yet the Soviet engineers continued refining the design rather than abandoning the effort. Luna 9 finally launched in January of 1966 aboard a modified R-7 rocket. The complete spacecraft weighed more than 1,500 kilograms and was approximately 2.5 meters long. Inside that larger vehicle were the power supplies, propulsion equipment, and other systems required to travel to lunar orbit and then descend toward the surface. The actual lander was much smaller, a metal sphere about the size of a beach ball. Despite its appearance, it was not simply another satellite in the style of Sputnik. When Luna 9 reached an altitude of roughly 75 kilometers above the moon, it inflated two protective airbags around the landing capsule. It then ignited a braking engine and reduced its speed until it was moving at nearly zero relative to the ground. As the spacecraft continued dropping, two small engines mounted on its sides helped guide and control the descent. At only about 5 meters above the surface, a contact rod detected the approaching ground. That signal shut down the descent engines, and the metal sphere was released from the rest of the spacecraft. Inside its inflated airbag, the sphere struck the lunar surface at approximately 6 meters per second. It bounced repeatedly, skipped across the ground, and eventually rolled to a stop. Once it had settled, the airbags deflated. 4 petal-like panels unfolded, righted the probe, and opened the way for its scientific instruments. Luna 9 had achieved something no spacecraft had ever done before. It was the first vehicle to make a soft landing on the moon, or on any world beyond Earth. The landing site lay in a region known as the Sea of Storms, and as the Soviet engineers hoped, the lander did not disappear into a deep layer of lunar dust like a vehicle sinking into quicksand. When the sun rose above the lunar horizon, Luna 9 extended its most important instrument, a television camera. The probe could finally look out across the landscape around it. As was common throughout the Cold War, the Soviet Union tried to keep the mission as secret as possible. American observers could detect a rocket launch without much difficulty and follow a vehicle while it passed through Earth's atmosphere. Once the spacecraft reached space, however, it was far harder to determine exactly what it was doing. At the time, a radio observatory in England happened to be carrying out astronomical observations. Its instruments began receiving an unusual radio transmission from the direction of the moon. The researchers understood enough about radio communication to recognize that the signal contained pictures. In fact, it used the same general radio frequency that newspapers employed to send photographs across the world. The observatory contacted a newspaper in London, and the paper brought out a fax machine in an attempt to decode the Soviet transmission. There was an immediate technical complication. Nobody knew what sort of image the Soviets were sending. The signal delivered the picture one horizontal line at a time, but it did not indicate clearly where one line stopped and the next began. The technicians made their best estimate, reconstructed the message, and printed the result. What emerged looked like a harsh, broken landscape, a field of jagged rocks and shattered fragments. London newspapers quickly began circulating that image around the world. In a strange twist, the Soviet Union was briefly beaten to the announcement. The London press appeared to have published the first photograph ever received from the surface of the moon, taking away the publicity the Soviet program would otherwise have enjoyed. There was just one problem. The newspapers did not possess the genuine photograph. Their picture was a distorted reconstruction of the lunar surface. They had come surprisingly close, but the image was still wrong. When the Soviet Union released the real photograph transmitted by Luna 9, the landscape looked nothing like the jagged field shown in the newspapers. It was comparatively smooth and flat, with very little that looked dramatic or unusual. A few craters could be seen farther away, while several ordinary-looking rocks lay scattered near the landing site. That result was welcome news on both sides of the space race. It showed that the moon's surface was stable enough for the relatively primitive landing systems of the time. The fear that a spacecraft, or a person, might vanish into bottomless dust had not been borne out. With that uncertainty removed, the contest moved to its next goal, placing the first national flag on the lunar surface. At that point, neither side could afford to think small. They would have to commit to an enormous undertaking or accept defeat before the decisive stage of the race even began. The basic difficulty of sending people to the moon always comes back to mass. A human being alone does not weigh very much compared with a spacecraft, but an astronaut cannot travel as a bare human body. The crew needs air, water, food, clothing, cooling, protection from radiation and temperature extremes, equipment for working on the surface, and a spacecraft capable of bringing everyone safely back to Earth. All of those requirements accumulate into a tremendous amount of mass, and moving that mass from Earth into space requires far more than simply building a vehicle large enough to hold it. Every kilogram lifted away from Earth must first overcome the planet's gravity, which means carrying additional propellant, which in turn adds even more mass to the vehicle. That meant both superpowers needed an absolutely enormous rocket, and throughout the middle of the 1960s, that was exactly what they were trying to build. The American vehicle was called Saturn V. Much of its design work was led by Wernher von Braun, an exceptionally talented rocket engineer who had previously worked for Nazi Germany. After the war, he came to the United States and offered his expertise to the American space program, with the understanding that his earlier involvement in war crimes would effectively be set aside. The United States decided that this was an acceptable bargain if it helped get people into space. The Soviet Union was developing its own heavy-lift monster, the N-1. It was originally intended to be another joint effort between Sergei Korolev and Valentin Glushko. Instead, the two men became locked in a major dispute about which kind of engine the rocket should use, and Glushko eventually left the project. The Soviet program then had to bring in a replacement who was not as capable when it came to designing rocket engines. As if that were not enough, Korolev died unexpectedly while undergoing what was supposed to be a routine operation. That left the engineers who remained in the Soviet program trying to complete the N-1 without the people who had been central to its development. The results were not encouraging. When the rocket finally launched for the first time in February of 1969, it stayed in the air for only about a minute. Then it caught fire, exploded, and fell back toward Earth. NASA's Apollo effort was moving more successfully, although it had suffered its own terrible disaster. 3 astronauts had been burned to death in an electrical fire inside an Apollo capsule. The Saturn V itself, however, was performing with remarkable reliability, and NASA had already carried out several rehearsal missions between Earth and the Moon. By the summer of 1969, it was clear to almost everyone that the Americans would send the first human beings to the lunar surface, and that they had a very good chance of completing the mission successfully. The Soviet Union still had one last desperate possibility. It could not realistically put a cosmonaut on the Moon first, but perhaps it could send a machine instead. A robotic spacecraft might land, gather a small quantity of lunar soil, and bring that sample back to Earth before the American astronauts returned. If that happened, the Soviet Union could at least claim to have been the first nation to bring material back from the Moon. It would not equal a crewed landing, but it could take away some of the impact of NASA's achievement. Most people knew nothing about the plan at the time. 3 days before Apollo 11 launched its lunar mission, on July 13th, the Soviets sent Luna 15 toward the Moon. The Americans detected the launch and were able to follow the spacecraft as it traveled outward. They chose not to make the information public. Even Neil Armstrong, the commander of Apollo 11, was not informed until he and his crew were already on their way to the Moon. It is still surprising how few people realize that 2 spacecraft were operating near the Moon during the Apollo 11 mission, one of them belonging to the Soviet Union and carrying no astronauts. Yet that was exactly the situation. There was also a specific reason this secret attempt disappeared from public memory. Luna 15 reached the Moon before Apollo 11 did, but the Soviet controllers struggled to decide where it should land. Rather than committing to a site immediately, they left the probe circling the Moon for several days. The delay continued for so long that Neil Armstrong and Buzz Aldrin actually landed on the lunar surface while Luna 15 was still in orbit above them. That began to create serious anxiety in Moscow. If the probe did not descend soon, there would be no chance of collecting a sample and returning it to Earth before the American crew. Eventually, the controllers selected a landing region called the Sea of Crises. The name alone seemed like a warning that the mission was heading toward trouble. By then, Armstrong and Aldrin had completed their moonwalk and were preparing to leave the surface and climb back into the Apollo lunar module. At almost the same time, Luna 15 began its landing sequence. During the descent, one of its engines shut down too early, and the spacecraft failed to maintain the proper angle. Instead of continuing downward in a controlled path, it began sliding sideways across the lunar terrain at almost 500 kilometers per hour. At some point, according to the prevailing reconstruction, Luna 15 struck the side of a mountain. The impact occurred roughly 560 kilometers from the place where the Apollo 11 lander was standing. That is where many people assume the story ends. America wins the race, the Soviet Union loses, and the matter is settled. But the history is not quite that simple. The years that followed Apollo's landing became the Soviet Union's most productive period of lunar exploration, even though that achievement has remained largely unfamiliar outside specialist circles. After the American landing, the Soviet engineers still had one of their original 3 technological paths available to them. This was an automated lunar rover called Luna, a name described as meaning moonwalker in Russian. Work on the vehicle had started during the early 1960s under Korolev, and the project continued after his death. The rover was not a minor side experiment. The Soviet Union constructed a full-sized imitation of the lunar environment in a desert testing area, which they called Lunadrome. There, engineers tested a succession of different machines and tried a wide range of ways to move across the surface. Some prototypes used legs, others were built with skis, tank-like tracks, or wheels. Teams worked around the clock, with some engineers even sleeping inside the laboratory because they were determined to get the rover ready before the Americans could achieve something similar. The final design had an unusual appearance. It looked rather like a bathtub mounted on wheels. The vehicle measured about 2 meters in length and 1.5 meters across. It rode on 8 metal wheels, and each wheel had its own small electric motor, allowing it to be powered and controlled independently. A hinged cover sat on top of the rover. When the cover opened, it exposed an array of solar panels. When it closed, it helped insulate the vehicle and shield its equipment during the long lunar night. That arrangement reveals how long the machine was intended to remain active. At a given location on the moon, sunlight continues for about 14 days, followed by roughly 14 days of darkness. The rover was designed to survive 3 complete cycles of daylight and darkness. To keep it from freezing during the extended nights, it carried a piece of decaying radioactive material that produced heat. That small heat source was meant to keep the internal systems warm while the sun was below the horizon for 2 weeks at a time. The equipment carried by the rover was equally ambitious. 4 television cameras allowed controllers to see the landscape around it. A mechanical digging instrument could collect lunar soil. The vehicle also carried a cosmic ray detector, an X-ray telescope, and an X-ray spectrometer. In addition, it included a laser reflector that could be used to determine the distance between Earth and the Moon with great precision. For its era, this was an extraordinary machine. Once again, the Soviet Union had a genuine opportunity to accomplish something historic. The first lunar rover was launched in February of 1969, 5 months before Apollo 11. Most people are unaware of that attempt, however, because the rocket carrying the rover exploded in mid-air. Rather than publicly acknowledge the failure, the Soviet authorities preferred to act as though the launch had never happened. Failure did not end the effort. In November of 1970, the Soviets tried again. This time, Luna completed the journey to the lunar surface and landed in the Sea of Rains. The landing system worked by placing the rover on top of a rocket-powered platform. Once the platform touched down, a ramp unfolded, allowing the vehicle to drive down onto the moon. That made Luna the first robotic vehicle ever to operate on the lunar surface. Control of Luna was taken care. The rover was controlled by a team of 5 engineers based in Moscow. They used a joystick to guide it across the lunar surface, but every maneuver had to account for a delay of roughly 30 seconds between sending a command from Earth and seeing that command carried out on the moon. The vehicle was not exactly moving at a thrilling pace. It had only 2 speed settings, 1 km per hour or 2 km per hour. Even at those modest speeds, Luna 1 managed to travel 11 kilometers across the lunar ground and continued operating for 11 lunar days, a period that amounted to almost 1 Earth year. Throughout that mission, it transmitted approximately 20,000 photographs and carried out 500 examinations of lunar soil. The achievement was largely eclipsed by what the National Aeronautics and Space Administration was accomplishing through the Apollo landings at the same time. The Soviet rover did not uncover anything that the American astronauts had not already investigated directly on the surface. That comparison, however, should not diminish the extraordinary nature of the mission itself. In 1970, operating a remotely controlled vehicle on the moon was an astonishing technical accomplishment. In fact, the National Aeronautics and Space Administration has still never carried out that exact kind of lunar rover operation. The people who designed and operated Luna also demonstrated how valuable their experience was years later. During the 1980s, they were brought out of retirement to assist the Soviet government in building remotely controlled bulldozers. Those machines were needed to clear radioactive nuclear waste from the Chernobyl power plant, where sending people into the most dangerous areas would have been far more hazardous. The Soviet effort did not stop there. In 1973, after the final Apollo expedition had come to an end, the Soviet Union sent another rover to the moon. Luna 2 continued the work begun by its predecessor. Even that was not the end of the country's lunar ambitions. Soviet missions kept returning until 1976, when Luna 24 attempted to bring lunar material back to Earth. The mission once again targeted the Sea of Crises, and this time, the landing and collection effort succeeded. The lander drilled deep beneath the surface and extracted 170 grams of lunar soil. That material was transferred into a return capsule, which launched from the moon, traveled back toward Earth, and eventually descended by parachute into the desert of Kazakhstan. When researchers examined the sample, they found what was then the first evidence suggesting that water existed on the moon. It was such an unexpected result that almost nobody outside the Soviet Union accepted it at the time. The prevailing assumption was that the water had been introduced accidentally through contamination from Earth. That interpretation remained common for decades. Then, roughly 5 decades later, the major powers of the modern era began competing once again to secure access to the Moon's known water deposits. The National Aeronautics and Space Administration has long maintained its own claim to a central place in lunar exploration, and that recognition is justified. Yet it is equally impossible to dismiss the Soviet contribution. Their missions revealed important parts of the true character of Earth's closest celestial neighbor, from remote exploration to the recovery of material from beneath its surface. The Soviet Union pursued an equally determined campaign at Venus, producing discoveries about the most violent planet in our solar system.